Hello. In this video, we're going to go through and show how to find the length of a line segment formula. This is a really useful formula when working in coordinate geometry, and it's heavily tied to the Pythagoras theorem. I'll come back to this a lot if you watch my videos or if you're in my class. I'm really bad at memorizing things. I tend not to memorize a lot of things. Things will naturally become memorized the more I use them, but I often have to go back and prove where things come from. And even if you're really good at memorizing, I think especially if you're really good at memorizing, you should go back and try and understand how something is developed, because in doing that it will give you greater access to concepts later on, because eventually your memory won't be enough. You'll have to understand what you're doing, and that's a really important realization as a student. So the formula we're going to explore is L, length, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's scroll down here and let's dive in and let's see where this comes from. So let's start with two lines that I could easily find the length of. So if I take a line here, we're going to give 2 points. We're going to make a vertical line here in blue. Now, we can very quickly see that this is the point 2, 1, and we can very quickly see that this is the point 2, 4. Now, right away, you might say, okay, well, I can tell very quickly that the length of this line is 3 units. And that's true. However, we want to kind of imagine what happens if we couldn't easily read this off the graph. Let's say instead of being nice integer values, these were decimals, ugly values, and it was a little harder. Don't mind that. That's just a meeting request going off. Well, what we can do here is we see that the y components are different, but the x components are the same. So to figure out the length of this, we can simply take 4 minus 1, which is equal to 3. So notice I took 4, which is that value there, minus 1, which gives me 3. The length of this line doesn't change in the horizontal direction. Well, I can now let's take another one. Let's do a different type of line. Let's do this one. This point we see is 1, negative 2, and I see this point is 4, negative 2. And again, I can read off this very quickly that the length of this line segment is 3. But what we want to understand is that, well, how do we do this if this weren't nice numbers? Well, since the y components are constant, we can ignore those. And what we can do now is we can take the x components. So I can see here that 4 minus 1 is equal to 3. So what we're doing here is we're taking, in the first case, the vertical line case, we're taking one of the y values, let's call it y2, and we're subtracting the other y value, let's call it y1. And that's equal to the change in y, right? And for the x values, if we're taking x2 and we're subtracting x1, and that's the change in x. So now let's imagine if this line wasn't vertical or horizontal. Let's imagine instead if the line was like this. Actually, let's go a little bit like that. So right away, if you're ever given a line, it's always good to get those points on that graph. Now, in this case, I can't read easily what the length of this line is. But what I can think of is I can actually break this line up into its vertical and horizontal parts. If we take this part here, if we take this and we just kind of do this, and then we take and do this, we put a point there, we know that this point here is going to be is going to be 5, 1, right? So we can easily figure out what the length from here to here is, right? Just because this is simply a vertical line, and we can easily figure out what the length from here to here is, because this is a horizontal line, and then we can apply Pythagoras' theorem. So if we call this length here L, we know that L squared is going to equal to, and let's start with the horizontal. So if we have 5 minus 1 squared plus, and now we're going to take the vertical, 4 minus 1 squared. So we could say L is equal to the square root of 5 minus 1 squared plus 4 minus 1 squared, which is equal to the square root of 4 squared plus 3 squared, which is equal to the square root of 16 plus 9. I'm writing a lot of steps here just to kind of help any person that's watching this. Square root of 25, which is 5. So we know the length of this line is 5. Now I'll be honest, I picked these numbers purposely so it came out to a nice integer value, but it isn't always going to work out. So what we see is that if we want to find the length of a line segment, we can break it up into its vertical and horizontal components and figure out the length of those two and apply the Pythagoras theorem. So finally, let's do this in a general case. So let's draw a line here, and let's call this point x1, y1. Let's draw a line to there, and we'll call this point x2, y2. So what I'm going to do is I'm going to do this in the general form. So I'm going to find L squared, and that's equal to, well, if we drop our line like this and we drop it across, we make a right angle triangle, the point here is going to be x2, y1. So we see L squared is x2 minus x1 squared plus y2 minus y1 squared. And we want to find the length, so let's isolate for L. So the length is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, and we're done. And this is the formula to find the length of a line segment. So again, you should memorize this in time just from naturally using it, but it's really important to understand where it comes from. The more practice you put into understanding where these formulas come from, the more success you'll have with math later on. In our next video, we'll look at how to actually apply this formula to some concrete cases. I hope this helped.